Hello, everybody. Look at this, we're live. 36 people. Hey, Adam, Alex, Alison, and Betty, Brian.
Hello,
Ooh,
guys.
Sophia, Christy, Colin, Donna. Oof, so many people.
Feels like romper room.
Hey, Geeta, Grace, Haley, Henny, Julia, Lakshmi, Leanne. Wow, you're all here for Sylvia, I know it.
Oh, sure.
All right. Well, thank you so much for your patience. I guess we'll get started. Thank you again for being here after a long day at school. We really, really appreciate it. My name's Catherine Roon, and I have the privilege of being part of the science publishing team, and I've got other members of the team here too, Nadia, Theo, and Jess. But today's not about us, it's about you and science and New South Wales. And so speaking of science in New South Wales, handing it over to you, Sylvia, that you run the show.
Hi. Thank you, guys. Thank you for having me. Sorry about the delay in my things, but technology is not working for me today at all. This morning, teaching in my classes, I was kicked out 3 times, changing laptops, etc. Okay, I will do the acknowledgement of country first. Right, I'm coming from Darkinjung land here in the Central Coast, so I would like you and invite you to put in the chat the country that you are joining me today. So I acknowledge that I operate and function on the lands of the Darkinjung people, and that we are all on the lands, country, and place of the First Nations that we meet today. We pay our respect to these lands and its peoples. We acknowledge those ancestors that defended, walked, and managed these lands for many generations before us, and who have left a legacy of a strong culture of wisdom and knowledge embedded in these lands today. We acknowledge and recognize all Aboriginal people who have come from other First Nations groups and who have now come to call this country their home. We acknowledge our elders, who are our knowledge holders, teachers, and pioneers. As educators of First Nations people, we empower our youth, who are our hope for a brighter and stronger future, and who will be our future leaders. And I pay my respect to my own Indigenous ancestors. My grandmother looks exactly like her. From my country of origin, from which I have learned to pass traditions and culture to my own children. Thank you.
Amazing. Thank you. And thank you to everyone in the chat for actually sharing the land which they are joining us from today. So back to our main part of today. And all right, Sylvia, I will control. While you take it away.
Thank you so much. So today we are going to talk about data and how Science in Focus can help you to teach data in science. Sometimes we get a little bit apprehensive about this, but it's not that difficult, right? And probably you're already doing it without realizing. So we're going to talk first a little bit of a curriculum and where data is fit in the new syllabus and what we're doing. We're going to do a little bit of hands-on demonstration activity that if we were face-to-face, we're going to do it. But because this is online, right, I will do a demonstration how can you do it in the classroom. And then we are going to be open for your questions and answers. Thank you. Next slide, please. So what's happening with data science and the curriculum? We have to understand that data science is a process, right? It's not just a product that the kids took an average or made a graph or do a table, right? It's about that thinking process and collecting that data and analyzing that data, right? To identify that data will become the evidence to support an hypothesis, to make more predictions, to make more inferences about what that data is telling us. You have to see data as a story. Numbers, data information, tell us a story, right? So you have to tell the students that when they see a set of data collected, I don't know, measuring temperature, right, in a table, that is related actually to story behind that, right? So the students will have a question. You will pose a question to the students. They are collecting that data. They're going to processing that data, analyze it, etc., and they are going to communicate. So it's not just a product, it's the entire process of working scientifically that we are tackling here. Next one, please. So in here you have all the stage 5, well, common to stage 4 syllabus, new working scientifically outcomes. And every single of them are related to data. And all the other ones, the knowledge outcomes, right? They have them embedded into it, right? If you were very familiar with the syllabus, right? Each of those focus areas will have 1, 2, 3 of these working scientifically, and they are related to data. So nearly half of the content in the syllabus is data related. Next one, please. So what's happening in here? What do we expect? What is required to teach data science, right, in stage 4 and in stage 5? So in general, we need that sense of inquiry and reasoning around the data. We need that data analysis, and we need to evaluate and critique, right? So in data science 1, if you remember from the syllabus, we have the students has to identify and use a range of sources of data, primary data and secondary data. They have scientific models, they have the application of the models, they have to formulate questions, they have to collect and analyze data. And then in stage 5, data science 2, they have to investigate more claims, they have to analyze pseudoscience, they have to analyze large data sets, and they have to include a more refined statistical analysis, right? That we call descriptive statistics. Next one, please. Okay. So when we are going to analyze this and we are going to reach a conclusion, I like this framework, right? We present to the students an inquiry question. We present a claim, right? That the students need to answer. To answer that, they need evidence, right? And that evidence is actually the data that they are collecting, that they are going to support the claim. So therefore, the experiment, the collection of data has to be valid. The test that we do has to be fair, right? And it says in there that it has to be appropriate and sufficient. That is the validity of the data, the reliability of the data. We all know that, right? As a scientists and science teachers. And finally, in the rationale, we have to justify the link to that evidence to the claim, right? From that evidence to the claim, and using scientific concepts and principles, right? So when we do the activity, I'm going to give you an example of how this works. But what we are going to do in stage 4 and 5, yes, thank you. The next slide, Kath, thank you. It's going to be link of what we are going to expect the students to do in stage 6. And if you were reading the draft of the syllabus of stage 6, a lot of them, right, will have very prescribed analysis of data in different experiments, and different experiments and concepts are going to have a claim. They're going to have an inquiry question. They're going to pose a inquiry question for the students, or allow the students to think of one. Think about the depth studies, for example, in those in stage 6. So all those skills that they are going to gain in data science in stage 4 and 5 has extreme applicability in stage 6. And we all know that, right? But sometimes we are scared. Okay, let's do a simple activity, right? I'm going to demonstrate this. Move to the next slide, but I will need to share my screen in a minute, so I will take over, not yet. So this activity is called Snake Stats, right? And I got a packet in here of snakes. Yes, you can give this one per group of students. And we are going to test 2 claims in here. You can ask the students and write on the board whatever claim you want. I have put in the slide, what is a claim, right? Because we are going to use it a lot, right? In our textbook, the claim is a statement that asserting something that is true, real, or a fact, right? So we have 2 statements in here, that there are more red snakes than any other color snake, or another one, all snakes are the same length. Now, I said before that the students has to gather different type of data. Now, put in the chat what type of data we are collecting in claim 1, and what type of data we are collecting in claim 2. Sorry, Colin?
Yeah, Collins just asked a question. Do you draw any link
yeah.
between claim and hypothesis?
Yes, so the claim is there are more red snakes than any other color snake. You can convert that, thank you, Christy, into a very important, into an hypothesis, right? Saying the independent and the dependent variable, depending of the level of your students. You can introduce this activity at the beginning, you know, when you are teaching quantitative and qualitative data. But yes, obviously, you can draw the link between the claim and an hypothesis. Yes, right? That's not a problem. This is the claim. This is how we write the hypothesis. This is going to be the aim of the experiment. And then you can teach the students how to write each of them based on that claim, right? The wording, how the wording changes from hypothesis to aim, right? But still responds to the claim. Exactly right, Leanne. Exactly. So, what is going to happen in here? What scientific questions or hypotheses can we generate from these 2 claims? How might those questions guide the scientific investigation? What is the type of data that we are going to use for that? So post in the chat, right, one scientific question for each of the claims. Could you go back to the claim, please? There are more red snakes than any other color snake. What a scientific question or hypothesis can we have about it as an inquiry question? Quantities, there are more snakes. Yes, it's considered quantitative, but we are observing qualitative. Yeah, qualitative data can be quantitative data. That's not a problem. Yes, Craig. Yes. Okay, on the chat, an inquiry question about the first claim or the second one, please, and see what we can come up with. It's really good when it's face-to-face, this type of activities, right? Thinking time. No idea. Too late to think. Let's see. I'm going to. Yeah, exactly right. You just put the statement into a question. Excellent. More popular, right? Yes. Are you eating more red snakes than others, right? Yes. Good. You can use preferences, people preferences as well. Could you please move to the next one, please? Thank you. All right. So what I'm going to do now, I'm going to take over and I'm going to grab my, oops, wrong camera. Grab my, share my screen and see if this camera is working now. Yes, it is. Wait me 1 second and I'm going to share my screen and move all of you away. From here. Oh, it didn't share the camera that I wanted. I'm going to stop sharing. So I want to share that camera. It's not allowing me to do. See, the technology is not very sympathetic with me today. I'm going to share it again. There you go. So I got the packet of snakes. I'm going to put it down. There was a claim more red snakes than others. Are we considering this red or not? Or that is going to be like a wine burgundy color? So we separate all the colors. You can do this with the students, and you can tell the students, if you can control yourself not eating them, I give you an extra packet. So they can, right? And it happens with us as a teachers, right? So what's happening next? Next is this. We are going to count them, right? And and we are going to create a little graph. So you're going to give the students little post-its like this one, right? And we are going to, I lost my pen here. In here, we're going to make, okay, red. There are 1, 2, 3. There. Then the kids are going to do this in class. Yellow. I actually did this with my science extension students the other day. How many yellows? 3. And we do a lot. I did a lot of statistics with them. Orange and so on, right? 2 and so on. So green, 2. So if you have a class of 30 students, 5 groups, 10 groups, you can do it individually to collect more data, right? I'm going to move things away. Now that I count all my snakes, right? And then on the board, I'm going to show you the strings in a minute. On the board, you're actually going to draw this, right? And then I'm going to put colors, numbers. And the students come and walk, right? So put 0, 1, 2, 3, etc. And the students come and walk with this on the board and put the little sticky notes there, right? Orange 2, so this is going to be orange. And this is going to be red, and this is going to be green, etc. Oops, spelling. And then, and yellow. So yellow is 3. And red will be 3. And then if you have more students, right? Let's see that another packet have 4 yellow. Sorry about my throat today. So you're going to start creating like a sticky note graph on the board, right? So we're coming back to your screen. Catherine, please. I'm going to stop sharing. You can grab that one. I lost it. Yeah. Yes. So as you can see in the screen now, this is a type of graph that you are going to get on your board using the snakes. And then you can discuss with the kids, what type of data is this? Is continuous, is discrete, right? Why we have to graph this? Or you can say we create a table first, and then from there or from the graph, we create a table. Why we have a column graph and not a line graph, right? What is the name of this graph? Column graph. Why is not a histogram? So doing this, you can actually introduce to a lot of data vocabulary to the students, right? Another one that you can do is actually measuring. Next slide, please. Measuring the length of the snakes, right? So using a ruler, you can say, okay, got my little ruler here. Oh, my camera is not on because I was with the other one. Sorry. Got my ruler here. I measure the snakes and I measure, okay, this is 12 centimeters for an orange, or the red ones are longer than the other one. This is another 10 centimeters and so on. So you can collect data, right? Quantitative data as in a different way, right? And again, you put it in the post-it and you create the graph using those. And then you have these ones. And you will see that the data in this case doesn't show a clear column as the other one, right? And you can pose these kind of questions. Why do we have different measurements? Do we have errors? You can introduce errors. Did you put the snake from the zero of the ruler, right? So you can, as I said, introduce with such a simple activity a lot of data terminology, a lot of use of the data, right, in your classes. If you want to do this online because you're teaching distance education, for example, you can create a Google spreadsheet and the kids can type all the information in the Excel spreadsheet. And then from there, you can create the graphs straight away, right? And you are creating a large data set, right? And the kids can collaborate in organizing the data in a Google spreadsheet. Next, please. Now, what's happening with here? We got all the information. We got all this. We need to go into the next step of that descriptive statistics that we call it, right? To take averages, to introduce line of the best fit. So next, please. So in the book, we have all explicitly explained in chapter 2, right? Where the students can go there and refer, and you can refer as well, how to take averages, how to do a medium mode, probably for stage 5 or 6. You can use these references as your stage 6 classes, how we do the line of the best fit, how we correlate two variables, right? We can correlate color and length, for example, a little bit weird, but it can happen. So you can put the kids in learning and don't be scared to manipulate data. As I said before, you can actually, you're actually doing it. But now we put names and we put more information into it. Please, next one. So if we take averages of those lengths, probably in here there are only 3 dots, but if you put the data of the entire class, you are going to have a cloud of information in here, and you can put the line of the best fit for the kids. You can, if you're doing this in Excel, you can actually teach the kids how to create a line of the best fit in the cloud of dots, right? In the scatter plot graph. So once we have this in front of the kids, you can actually, when I was doing this in face-to-face, I was actually having a ribbon, you know, putting all a ribbon across all the data and all those sticky notes, right? So the kids can physically see where the line of the best fit goes. And then if we put that data into an Excel and do it, you know, with the software, what is the differences of what we did on the board and what is in the actual Excel spreadsheet, right? So you are reducing error in the data, doing it in the spreadsheet, comparing with what we do on the board, right? So could you sort of following me how this can lead, simple activity can lead of a lot of talking about data and the vocabulary and the skills that the students are needed, right? Okay, so what is the data is telling us? For example, of the different colors, right? In our case, the ones that I put in with my little bag, the red ones were less than the other ones, and actually was the burgundy color, the ones that they have. But probably in the ones that you're doing in your class, the red ones are higher than the orange, or maybe that was the expected in the hypothesis. And this collection of data that needs to refute the hypothesis and put another new one and another new question in the analysis of the data, because the data is not showing what it was the hypothesis, because our one said that red snakes are majority and in my bag they were minority, right? So you're teaching the students that the data actually helps you to refute, accept an hypothesis, or refute or accept a claim, right? And not being biased about it, right? That's another important thing in data. So moving on. So again, with the same, with the length of the snakes, they were not identical, right? We can say to the students, based on the data that we collected, right? We need more evidence. We cannot support or reject the hypothesis. We cannot support or reject the claim. We need to repeat this activity. We need to repeat the experiment to collect more data, to collect more evidence, to be sure. Because with this little amount of dot points that we have in the graph, is not enough, right? So we cannot have a fair conclusion for this, right? So far, any questions, any comments about the activity? Any other ideas that maybe we didn't think about with this activity? You can talk to us or you can type it on the chat. No? Or no one understood anything? What I was saying? Oh, I was very clear. It could be for anything. I did this activity in a science extension, right? And you can move it up, you know, to higher levels. And we were talking about quantitative data, qualitative data, t-tests, you know, chi-square tests. We use the data for a lot of things. Exactly right, Gray. Exactly right. That's what I said, that if we put all the data in there, you will have a better cloud, right? For a better line of the best fit. Yes, good point. Thanks, Colin. Right. So I talked about the SERV framework at the beginning. So to write the conclusion of this, right? Yes, exactly right, Brian. That is the best way. Doing individually, if you have a class of 30, it's going to be very powerful, the amount of data that you got. Okay, so one of the claim was most snakes in the bag are red, which is not the example that I have, right? Next part. So we have the claim. Now the evidence says that red was most frequently or less frequently, right? According to the chart that we have. So in the one in the example in the PowerPoint has a lot of red snakes. The one I got in front of me, it has more burgundy snakes than the red ones, right? So in the conclusion, you teach the students how to write a conclusion. This is as well mentioned in the textbook, the SERV framework, right? So, and then you tell the students, and this is how the students fall a little bit when they write in conclusions. They put the aim of the experiment or the claim, they put the results, right? And then they never say why that is happening. Fair enough, Craig. Fair enough, right? Depends on the budget, yes. But you can use anything. We use snakes because the kids love it, right? But it could be anything, right? That they can be, you know, text pencils or whatever things, different colors, you know, marbles or whatever you can get. What's the other one? Paper clips of different colors, right? That you collected. Doesn't matter, right? Snakes are cool. That's all. It could be anything. Just buttons. That's a great idea. Yes, buttons is a great idea. So we need to teach the kids to write a proper conclusion. So in that conclusion has to be the claim. Yeah, that's a good one, Smara. Evidence, right? What is the data is telling us? What's the story? And then the rationale, right? So if you follow the third one, is the best way to do it. So move on. Yes, thank you. So if we align these to stage 4 or 5 of the working scientifically outcomes, they observe the colors, right? They were asking questions to formulate. Yeah, M&Ms are actually maybe more expensive than these ones. Oh, but you can have those little Skittles or little bags of M&Ms that it comes in big packages, right? So for questioning and predicting, the students actually generating the questions or the claims, right? To design the activity. They are conducting the investigation, so they are collecting the data, right? Then they are processing that data. They can take averages, they make a table, they make a graph, right? They analyzing those trends, how many they are here, how it looks like the line of the best fit, right? And then they are assessing those claims, right? In the data science actual syllabus focus area, and verify the claim and reject or accept the claim, reject or accept the hypothesis. Right, exactly right, guys. So I told you, if you don't eat it, you can have a second package at the end of the lesson. Fantastic. Thank you. Any other more comments about the activities or how to manage the activity with data science? What you mean, questioning and predicting? I don't get your question, Zoe.
It's the convention.
It's the time in the
we use.
syllabus. Yes.
Yeah,
the
it's
new
the convention that we
syllabus.
use. Yeah, so it's like
Yes.
stage 5, science, stage 5, working scientifically, and then it's kind of the dot point that's in there. So it's
Exactly.
just a way for us to, yeah.
Yes,
get a
it's
new
our
syllabus. Thanks,
thing.
Colin.
All coming from the new syllabus. So SC5 is for stage 5. Exactly right, Brian. Exactly right. Very simple. Yes, there are a lot of experiments that you already do to collect big amount of data that you can apply these principles. Exactly right. Exactly right, Rahila. Exactly right. Yeah, I hope that it's helping you to open your minds a little bit about data science, that it's not that scary, right? Yes, yes, exactly right, Rob. Catherine. Okay, cool. Next slide, please. Right. So how we are going to support you to help you to do this in data science? Yes, exactly right, Grace. It goes across all the stages. Keep in mind, guys, that if you have a very strong data science in year 7, and you build up from year 7 to year 10, you not have to be too worried in stage 6. So start with the vocabulary in year 7, right? With the term hypotheses and variables and averages and, mean, all that. Even if data science is focused in year 8, right, according to NESA, that doesn't stop you to start in year 7, right? Or embed data science, depending on how is your programming. You can embed data science across all the little units of work, which is a lot of work, right? In the textbook, we have a chapter related to data science, and across the textbook, we put little links. If you go to the next one, please. If we have in there links to videos, links to activities to reinforce that data collection, that skill, right? We have a lot of things that explain the students how to collect the data, how to analyze the data. All those skills are in videos. And if you go to the next one, please. And across the textbook in stage 4 and stage 5, we have these little prompts that you can say that links to different content to the data science things, right? So that helps you to say, oh, how can I use data for this? And, these are one of the videos that we call it Science in a Minute, right? When we give examples of different type of activities that maybe you can watch the video yourself and create a lesson from it, right? Or show the students and use that actual table that you see on the screen, for them to create the graph and analyze the patterns and the trends, right? So the book has a lot of them. And then as well, we have additional online practice questions related to data and data analysis and data collection, that they are word formats, right, Catherine? That the teachers can actually modify the worksheets.
The worksheets, yeah, the worksheets are downloadable. The questions that are online are already there and available for you as multiple choice, and they'll self-mark as well. So there are additional questions that we have as part of the science skills and the data science practice and consolidation.
Yeah, exactly. And because they are you can download it, you can actually tailor it to your class and differentiate it to your class, right? So we have scope and sequences, we have little programs, we have a lot of things for you in the book. So now Catherine is going to show you a little bit more of what we can offer in our textbook.
Sorry, can I confirm that you can hear the sound?
Yes.
Yep, okay, cool.
Spark engaging learning pathways for every student to ignite their science skills with Science in Focus Stage 4 and Stage 5 Nelson Mindtab. Prepare students for each chapter with pre-tests that provide immediate feedback. These assessments help students gauge their existing knowledge to identify areas for improvement. Learning checks in each module provide a succinct snapshot of students' progress as they learn key concepts and skills. And at the end of each chapter, differentiated end-of-chapter tests ensure you can effectively assess students' learning. Introduce working scientifically skills through our engaging Science Skills in a Minute videos tailored to introduce key topics. These bite-sized videos captivate students, making skill development a fun and interactive experience. Reinforce skills with our Science Skills in Practice digital activities, fully integrated with the student book content. These engaging exercises provide students with valuable interactive practice, consolidating their understanding and boosting their confidence in applying scientific skills. Course customization puts you in charge. Tailor modular lesson content to different learning needs by assigning tasks or assessments directly to a student or to the whole class. Add, rearrange, or hide content. You decide. Stay on top of your students' progress. With Nelson Mindtab's Gradebook Analytics, gain valuable insights into how your students are performing. Use real-time feedback and data to monitor where students need extension and where they need more attention. Then tailor your lessons to meet their needs. Access all this and more with Science in Focus Stage 4 and Stage 5 Nelson Mindtab, a comprehensive approach to learning and enabling students and excel in science. Make an appointment with your Nelson Learning Consultant to see how Nelson Mindtab can support you.
Thanks, Catherine. Could you, Catherine, go back to slide 23? I think some people are a little bit confused with the outcomes. I think it's slide 23. That one. Thank you. What we are listing in there was the title of the working scientifically outcome coming from the syllabus. The dot point below refers only to the activity that we were doing. It's not the wording of the syllabus. NESA has the copyright for that, right? So any textbook that actually mention the actual outcomes as it happens in our focus areas, we have to pay copyright, right? So, so a lot of things that has to be paraphrased, right? But that list of those outcomes, the titles, yes, are the same as the working scientifically in NESA, but the dot point below is just referring to this particular activity, right? Does that make the things clear, Zoe? Yes? Okay. Any questions or comments or any questions in particular that you need to ask about the book or the activity or any other ideas of activities that you are thinking of? And this will be an excellent spot, to discuss it and say, oh, I would like to do this, but I don't know how to, or how can I use the textbook for this or for that, right? So it will be an excellent tool, particularly for data science, having a separate chapter with all the vocabulary activities and different references, not only for stage 4 and 5, but as well for stage 6. This is like the class, right? The teacher asks a question and everyone just goes under the desk. Do you think that this has been valuable for all of you to grab ideas and to say, oh yes, I can use the textbook as a reference, and I can use the textbook to support me in the classroom with this type of concepts that they are not very common, and now they are prescribed for us to teach. Before they were sort of there, right? But now we have to teach it. Christy, happy ever after. Yes, exactly right, Grace. That's a very good question. In the chat about that, it says that many people are blending data science through all the units, right? And ticking the boxes. I give you an idea what I'm going to do in year 8, right? We are going to use data science as a science fair. So we're going to do that unit of work, and the kids can create a science fair. So they have their own projects, and they have to use all the data as they progressing in their research for the project to be presented in a science fair. We introduce all these concepts. And in year 10, we are doing a science symposium, right? So those are examples that we can use all this information from the textbook and guide the students using the textbook and using those working scientifically skills in chapter 1, you know, to apply that into their own research project, right? So that is an idea. But if you are sitting, you know, and said, oh yeah, I tick the box in here for this unit of work, for this part of data science, that is okay. The book will guide you as well to use and embed data science in different units, because we indicated that beside each of the concepts that we consider that is more valid to, you know, link it in there. That was a question from Sivani, I think. If we buy the class set, can the students access to all the online resources? That is a question for you, I think, Kath.
Yep, it's just been answered by Theo. Thank you in the chat.
Okay, thank you. Yeah, depth studies as well. Yes, of course. Yes, if you use Google, Data World is a great website that you can use data. I think there are a lot of links and references in the textbook, in the Mind tool as well. Yes, there are. Yes, Lakshmi, there are plenty of analysis of data in the diseases chapters. Yes, of course. So in the physics or geology, yeah, we put a lot of experiments and activities with a lot of uses of data and linked to the chapter 2 for both textbooks. Yes, we do. Yes. Particular in diseases that they have to do some comparison of between infectious and not infections, and epidemiological sort of like geology. There are in geology as well, right? Because one of our authors is a geologist, right? An environmentalist. So yes. Yes, of course. Yes, we do have examples with geology as well, and ecology as well, right? And art, we introduce art in science as well with observations in year 7. So you can use a piece of art for observations. That's a big one as well. Any other comments, guys? How can you extend this activity further with the snakes? What are the claims you can tell the students to do. We did one once in year 7, and make sure, check allergies, etc. Right? These natural snakes are, you know, all the things free that you can imagine. And then we did a claim that we can identify the color of the snake by the taste. Right? So, yes, that's another good one. Weigh them. Right? Excellent. Yes, 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 that's a great one. Yes, exactly. Validity and reliability. It was really interesting to cover the, you know, blindfold the couple of students. We give them the snakes, and if they can taste, if yellow tastes lemonish or red tastes strawberryish, right? And it did not happen. They all sort of tasted the same according to the students. Yeah, you can talk about validity, reliability, obviously accuracy, precision. Yes, all those topics are in chapter 1 and chapter 2 in the textbook to guide you, with extra resources in there as well. Another important thing, at the end of each chapter, you have a depth study, right? So each focus area have a depth study. And then in there you have a downloadable depth study worksheet, and where some of them, the ones in the physics focus areas, they have a lot of data as well for the students to analyze. That's really clever, Owen. I like that. Yes, yes, that's a great idea. Yes, you combine different brands of snakes as well, you know. Yeah, exactly right. That's a really good one, Nadia. Yes. So see, you got all the ideas in there. Now you have to put those into the terminology and vocabulary of data science, right? It's not rocket science, right? It's just understanding that this is what we were doing, right? And now we have to apply more vocabulary, more knowledge, and actually explicitly teach it to the students. Right, I think we are okay with time. Any more questions or comments that you want to ask to the team? Related to how to get the book, what we get, what we don't get, etc. Right? I wrote it with the team, but all the people in here are actually from above me, right?
Awesome. Well, look, thank you so much, everyone, for your time. Really appreciate you hanging in there and also engaging in the conversations as well. And of course, thank you to Sylvia for such an amazing workshop and actually, you know, sharing some of your teaching strategies and your tips and tricks of how we can actually implement data science, taking such an easy activity and being able to stretch it so far to say even stage 6 maybe that we can extend it to. So thank you so much for everyone. And if you have any questions at all, please reach out to us. Really appreciate you. Thank you so much. Have a great night. Thanks, everyone.
There was a question in there, just confirming.
This was a resource. I think so. I think the people attending, yep.
Yes,
get
correct.
access to the resource. Yep.
Yeah.
Thanks, everyone.
Correct.
Thank you. Thank you, guys.
Thank you, guys. Thank you for having me. Enjoy the textbook. Bye-bye.
Thank
Take care.
you.
Bye.
Bye. Ooh.